Hello. One of the topics that comes up frequently when I talk to splits customers is the concept of consistency of treatments. If I have a split, how do I know that a particular user will get the same treatment every time? And so this video is about consistency of treatments. And we'll look at two different situations. One is consistency of treatments with percentage-based rollouts, and then another one with assignment of treatments and/or targeting rules when you use a targeting rule with an attribute check. But before we dive into the details of those two particular cases, let's review one of the fundamental principles about how split works. And that is the idea that every instance of the SDK, in this diagram on the left, located inside your application, and that application box could be a Java server application, it could be a JavaScript application running in a user's browsers, in which case there may be thousands of instances of those applications distributed across the internet. And each one of those split SDKs is working independently. When it initializes, it downloads the definitions of the splits, which include the targeting rules or the percentage-based rollouts. And every decision that each SDK makes is completely independent of any previous decisions. SDKs don't have any memory of what's happened before in terms of assignment of a treatment to a user. It does, in fact, record impressions, which are records of get treatment calls, but those are queued up and then periodically uploaded to the split cloud. And of course, an independent SDK separate from the one that generated the impression won't have knowledge of that particular assignment of a treatment. The key thing here is that every get treatment call is processed independently, regardless of what has happened in the past. So now let's look at how the split SDK maintains consistency of treatment in the case of a percentage rollout. So imagine we have a split, in this case, percentage-based rollout. We have 3 treatments, and our default rule is to allocate users a third to each of those treatments. So the question becomes, given the caveat I stated before that each targeting decision is made independently, how do we make sure that all those instances of the SDK assign a key consistently between the 3 treatments? Here's how that works. When a get treatment is called, a hash is computed. Every split has a unique seed for the hash, and then the key is fed into that hash. A number is produced, and that number is taken mod 100 to give us a number between 0 and 99. And we think of those numbers as 100 different buckets, each with a number between 0 and 99. So every key is going to get, no matter where the SDK lives, is going to get a consistent bucket for a particular split. And the way that maps to the percentage-based rollout is you can think of each bucket as appearing as 1/100th of that horizontal line representing the different mix between treatments. And so depending on which bucket a user's key falls into, that's where they fall on that horizontal line, and that's the treatment. The treatment that appears in that part of the line is the treatment they get assigned to. So in this case on the slide, any bucket between 0 and 29 would be assigned to on, and any bucket between 30 and 99 would be assigned to off. Where that user falls along the horizontal line, or which bucket they fall into, is consistent because it's mathematically generated in a consistent way by the hashing function. So that's how split maintains consistency for percentage-based rollouts. Obviously, if you change the percentage in the default rule or one of the targeting rules, then a user will move. If we made this be a 50-50 split, then everyone in buckets between 30 and 49 would suddenly move from off to on. But it would still be consistent for every instance of the SDK using that version of the rule. Let's turn our attention now to the other instance where we want to maintain consistency of treatments, and that is when using an attribute-based targeting rule. So here's an example, loan application split. We have 3 treatments, 2 discount interest rates, and then a standard interest rates. And then we have a targeting rule where we're examining the user's credit rating, and if it's between 670 and 750 inclusive, then we're going to give them one of these 2 discount interest rates, and if not, then they're going to get the standard interest rate. We're interested in seeing how users in these categories respond to discount interest rates in this experiment. So what happens if on day one, a user comes in and their credit rating is 675, so they're bucketed into this targeting rule. They get one of the two discount interest rates. And then a couple days later, they come back to look at the same offer, and their credit rating has dropped, and now their credit rating is 650, so they don't fall into that. Now, then they will see a different interest rate, and you don't want that to happen. Unfortunately, there's no easy way to deal with this within Split itself. We started this video laying out the principle that every targeting decision is made independently of anything that's happened before. So you're going to have to handle this yourself in your code. There's two options for doing that, both of which involve caching a value and associating that with the user ID. And there's two options here. One is the first time through, you call getTreatment and you store away the value returned by getTreatment and associate that with the user ID. And then pass, instead of calling getTreatment on subsequent runs through that code, you just use that treatment without calling the getTreatment call. The second option is to store away the current value of the volatile attribute and then pass the stored version of the attribute rather than the current version of the attribute and pass that to getTreatment. In general, I prefer the second option because that would still allow you to kill the split and have that take effect because the getTreatment call is being made, or even to change the percentage rollout for that particular targeting rule and have it take effect. Whereas if you're skipping the getTreatment call, then there's no control over the targeting of that split at all, since getTreatment's not getting called. With both of those options, you obviously need a way to cache the value and associate it with the user ID passed to getTreatment. And you need to preface the call to getTreatment with some sort of conditional that checks to see if that cached value exists. And in the case of the attribute, if it does, put that in the attribute list instead of the default value of the attribute. Or in the case of the treatment, check to see if the cached value of the treatment exists. And then don't call getTreatment if it does, and use the treatment that was cached. Also, you're going to need some way of turning this caching off so that when the experiment's all over and you want to just set everything back to normal and have getTreatment called with the normal values, you'll need a way to either change the code or have some resource property that you're looking up that says whether or not to take that special branch through the code. Finally, some takeaways from this entire session. Can't repeat it often enough that every targeting decision made by an instance of the SDK is independent of anything that's happened before, obviously independent of the future. That would be pretty cool if we could make it dependent on the future, but I'll take it as a feature enhancement request. Consistency for assignment of treatments with a percentage rollout. That's achieved by bucketing, which is done with a consistent arithmetic hash function. It's important to know that for the use of targeting rules that look at the value of a user's attributes, if the user's attribute value changes over time, their assigned treatment might change over time as well. So the final takeaway is when you sit down to plan your experiment, if it involves targeting with attributes whose values might change over the life of the experiment in such a way that it would cause the user to move between rules or treatments, you need to spec out a solution and incorporate that solution into your code. I hope this has been helpful. My name's Channing Benson. I'm Split's Experimentation Advisor.